Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving 2sum2 where input array is sorted. I will go over 2 ways to solve this problem, but we'll only go over the coding for the optimal solution. If you're only interested in the optimal solution, then feel free to skip to the timestamp. This problem is actually a continuation of 2sum1, so I recommend solving that problem first if you haven't, and I have also made a video about that problem, so feel free to watch that video first. So the problem states that we are given a one-index array of integers numbers that is already sorted in non-decreasing order, and we want to find two numbers such that they add up to a specific target number, and we let these two numbers be numbers of index 1 and numbers of index 2, and index 1 and both index 2 would be bigger than or equal to 1 and less than or equal to the length of numbers, and we want to return the indices of these two numbers, index 1 and index 2, and we want to add each index by 1, and we are guaranteed that there is exactly one solution for all inputs, and we cannot use the same element twice. So how can we solve this problem? One way that we can solve this problem is we can use a double for loop, so the pseudocode will look something like this, where one of the pointers starts here and the other starts here, and then we will compare as we go along. How a double for loop would work is the right pointer will first iterate through the entire array all the way to the end, and once it gets to the end, then the left pointer will shift over by 1, and the right pointer will be one index above that, and then it will iterate all the way to the right all over again. So the time complexity of this approach would be n squared because it is a double for loop, and there's actually a more efficient way to solve this problem. I think the fact that the array is sorted, it can help a lot because we can just use two pointers. So the left pointer being all the way from the left and the right pointer being all the way from the right. And we will add the two numbers at wherever these two pointers are pointing at. If the sum is greater than the target, then we will shift the right pointer to the left by 1. And if the sum is less than target, then we will shift the left pointer to the right by 1. And if the sum is equal to target, then we can return the two indexes. And we will continue the algorithm until we find the sum that equals to the target. So let's just go over this example. So the left pointer will start at 2 and the right pointer will start at 15. 15 plus 2 equal to 17. It's greater than the target, so we will move the right pointer. And now 2 plus 11 is equal to 13. It's still greater than target, so we will move the right pointer again. So now 2 plus 7 is equal to 9. And the sum is equal to the target, so then we can return these two indexes. And that would be our solution. And the time complexity of this problem would be O of n, because we may have to iterate through all the elements in the array, and n would be the length of the array. And the space complexity of this problem would be O of 1 because we are not using any extra space. So now let's get to the coding part. So first we're going to set the left pointer to 0, and then we will set the right pointer to the length of numbers minus 1. And then now we're going to set while left is less than right because the algorithm will continue while left is less than right. And the current sum that we calculate will be the numbers of left plus the numbers of right. So if the current sum is less than target, then we will shift left over by 1. Or if current is greater than target, then we will move right over to the left by 1. So right minus 1. Otherwise, that means it will be equal to target, so we return left plus 1 because we need to add 1 to the index, and right plus 1 because we need to add 1 to the index. Alright, let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any questions or comments, feel free to leave it down in the comments section down below, and I hope to see you all again soon.